Hi, welcome back. In our previous lesson, we looked at Hicksian versus Slutsky's decomposition of income and substitution effect. Today, we'll be moving on to deriving the Marshallian, Hicksian, and Slutsky demand curves. There are two ways to solve the consumer's problem. One way is to fix the budget and find the maximum utility that could be achieved, and the other way is to fix the level of utility and find the minimum cost given that level of utility. The first method, which is utility maximization, leads us to the Marshallian demand curve. The Marshallian demand curve shows the relationship between the price of a good and the quantity demand of that good purchased by an individual, holding all other factors constant. We notice that this is the ordinary demand curve we are used to in economics. Along a given demand curve, if the good is a normal good, as the price of the good increases, even though the nominal income does not change, the real income in terms of purchasing power decreases if the price increases, which induces a decrease in the demand of the good. We will use this idea to derive our Marshallian demand curve. Let's start with this figure here. This space will show the preference of the consumer for good X and good Y, which we will use to draw our indifference curve. And this space will show the relationship between the demand for good X and then the price of good X, which we'll use to draw our demand curve. We start by representing the indifference curves showing the consumer's preference for good X and good Y and the budget constraint. Our initial equilibrium is E1, at which the consumer consumes X unit of good X. If we project this X1 unit of good X into the diagram below, we can map the demand for good X at price P1, and this is represented at point A. At price P, the consumer demand for good X is X1. If the price of good X increases from P1 to P2, this will cause the budget constraint to pivot inward, bringing us to a new equilibrium point E2. Now, at equilibrium point E2, the consumer's demand for good X would decrease from X1 to X2. We can map this quantity downwards to show the demand at the new price P2. Let's call this point B. At price P2, the consumer's demand is 2. To draw a Marshallian demand curve, we simply have to connect the point A and B and several other points that may arise from similar adjustment. If we consider similar change in the price, which gives us a different budget and different equilibrium points, then we can map them to this demand curve at various points and then connect all of these points to give us a Marshallian demand curve. So if we call this DM is the Marshallian demand curve for good X, which summarizes the total quantity of good X at each possible price, P1, P2, and any other price in between or above and below. One thing we have to note here is that this demand curve includes both the substitution and the income effect. So any change in demand as a result of a price change is as a result of both the substitution and the income effect. So this is all that we have on the first part of deriving the Marshallian, Hicksian, and Slutsky demand curve. Our next lesson will be on part 2, where we focus on the Hicksian demand curve. If you enjoyed today's lesson, consider subscribing. Thank you.